2023 National Electrical Code, or NEC, does not mandate a 240-volt circuit for an electric range if the range's total load is 3.6 kilowatts or less. However, the code stipulates that the range must have a dedicated circuit. Regarding small appliance circuits, the NEC necessitates a minimum of 220-amp small appliance circuits specifically for kitchens. These circuits are designated to serve countertop receptacles. The NEC also permits powering additional appliances, such as range hoods, from these small appliance circuits. Considering a scenario with an electric oven having a 3.6 kilowatts load, a dedicated 120-volt circuit with a 20 amps breaker is suitable for installation. It is also permissible to connect the range hood to one of the small appliance circuits, provided that the circuit's load rating is not exceeded. To summarize, according to the latest NEC guidelines, a 240-volt circuit is not necessary for an electric oven in this case. Nevertheless, it's crucial to install the oven on a dedicated circuit. Furthermore, connecting the range hood to one of the required small appliance circuits is acceptable, as long as the circuit's load capacity is carefully observed. A dedicated circuit ensures that the oven receives a consistent and reliable power supply without being affected by other appliances in the same circuit. This enhances safety and prevents potential overloads. When connecting the range hood to a small appliance circuit, it's essential to calculate the total load on that circuit to avoid exceeding its capacity. This calculation should include the oven's power consumption and any other appliances connected to the same circuit. Overloading a circuit can lead to trip breakers, overheating, and potentially hazardous situations. Now let's delve further into the specifics of electrical circuits, breakers, and load calculations. Firstly, understanding the difference between 120 volts and 240 volt circuits is crucial. A 120 volt circuit typically consists of one hot wire, one neutral wire, and a ground wire, while a 240 volt circuit consists of two hot wires, one neutral wire, and a ground wire. The voltage difference arises from the way the circuit is wired to the electrical panel. Secondly, circuit breakers are safety devices designed to protect electrical circuits from overcurrents or short circuits. When the current exceeds the breaker's rating, it trips, interrupting the flow of electricity and preventing potential damage or fires. Breakers are rated in amps, indicating the maximum current they can safely handle. Thirdly, load calculations involve determining the total amount of electrical power that will be drawn by all appliances and devices connected to a circuit. This calculation is essential for selecting the appropriate breaker size and ensuring that the circuit can safely handle a load. The NEC provides guidelines and formulas for performing load calculations accurately. When working with electrical circuits, it's always recommended to consult with a qualified electrician. They can assess the specific requirements of the installation, ensure compliance with local codes, and perform the work safely and effectively. Attempting electrical work without proper knowledge and experience can be dangerous and may result in serious injury or property damage. Now, let's consider some additional factors related to electrical installations. One important aspect is the selection of appropriate wiring. The size and type of wire used in a circuit must be adequate for the load it will carry. The NEC specifies the minimum wire gauge for various circuit amperages. Using undersized wiring can lead to overheating and potential fire hazards. Another consideration is grounding. A proper grounding system provides a path for stray electrical currents to return to the source, reducing the risk of electric shock. The NEC outlines the requirements for grounding electrical systems, including the use of grounding electrodes and bonding conductors. In addition to safety, it's also important to consider energy efficiency. Using energy-efficient appliances and lighting can help reduce electricity consumption and lower utility bills. The NEC promotes energy conservation through various provisions, such as requiring the use of high-efficiency lighting fixtures in certain applications. Furthermore, the NEC addresses the installation of electrical equipment in specific environments such as wet locations or hazardous locations. These environments require special precautions to prevent electrical hazards. For example, in wet locations such as bathrooms or outdoor areas, ground fault circuit interrupters, or GFCIs, are required to protect against electric shock. GFCIs are designed to detect even small imbalances in current flow and quickly interrupt the circuit, preventing potentially fatal injuries. Regarding the specific scenario of connecting a range hood to a small appliance circuit, it's crucial to ensure that the range hood's power consumption does not exceed the circuit's capacity. The range hood's wattage should be clearly marked on the appliance. To determine the current draw, divide the wattage by the voltage of the circuit. For example, if the range hood is rated at 300 watts and the circuit is 120 volts, the current draw would be 2.5 amps. Add this current draw to the current draw of other appliances on the same circuit to ensure that the total does not exceed the circuit's 20 amps rating. If the total current draw exceeds 20 amps, it's necessary to either reduce the load on the circuit or install a separate circuit for the range hood. Overloading a circuit can lead to nuisance tripping of the breaker, which can be inconvenient and potentially damage appliances. In addition to the NEC, local electrical codes may also apply. These codes may have additional requirements or restrictions that must be followed. It's important to check with the local authorities to ensure compliance with all applicable codes. When planning an electrical installation, it's always a good idea to create a detailed plan or schematic. This plan should show the location of all outlets, switches, and appliances, as well as the wiring routes and breaker sizes. A well-prepared plan can help ensure that the installation is done correctly and efficiently. It can also be helpful for future troubleshooting or modifications. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, it's best to hire a qualified electrician. They have the knowledge, skills, and experience to perform the work safely and in compliance with all applicable codes. Trying to save money by doing electrical work yourself can be risky and may end up costing more in the long run if mistakes are made. Let's revisit the key takeaways regarding the electric oven and small appliance circuits. The NEC does not require a 240 volt circuit for an electric oven with a load of 3.6 kilowatts or less. However, a dedicated circuit is still required. The range hood can be connected to one of the small appliance circuits, provided that the circuit's load rating is not exceeded. It's important to perform load calculations to ensure that the circuit can safely handle the combined load of all appliances connected to it. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. Remember, electrical safety is paramount. By following the NEC guidelines and local codes, you can ensure that your electrical system is safe, reliable, and efficient. In addition to the points already covered, let's consider the type of receptacle to use for the 120 volts 20 amps dedicated circuit for the electric oven. The appropriate receptacle would be an MF5-20R. This receptacle is specifically designed for 20 amp circuits and has a different slot configuration than a standard 15 amps receptacle, preventing the accidental plugging in of appliances that draw more than 15 amps. It's important to use the correct receptacle to ensure proper electrical connection and safety. Now let's discuss the importance of arc fault circuit interrupters, or FSIs. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults can occur due to damaged wiring, loose connections, or faulty appliances. FSIs work by monitoring the electrical current and detecting abnormal patterns that indicate an arc fault. When an arc fault is detected, the FSI quickly interrupts the circuit, preventing a fire from starting. The NEC requires FSIs in many areas of the home, including bedrooms, living rooms, and dining rooms. While FSIs are not typically required for kitchen circuits, it's a good idea to consider installing them for added protection. Furthermore, it's important to periodically test your GFCIs and FSIs to ensure that they're functioning properly. Most GFCIs and FSIs have a test button that can be used to simulate a fault condition. When the test button is pressed, the device should trip, interrupting the circuit. If the device does not trip, it should be replaced immediately. Regular testing of GFCIs and FSIs is essential for maintaining electrical safety. In addition to the electrical code requirements, it's also important to consider the practical aspects of electrical installations. For example, it's often a good idea to install more outlets than the minimum required by code. This can provide greater flexibility and convenience in the future. It's also important to consider the placement of outlets and switches to ensure that they are easily accessible and convenient to use. When running electrical wiring, it's important to follow proper wiring practices. This includes using the correct size and type of wire, securing the wiring properly, and making sure that all connections are tight and secure. Loose connections can lead to overheating and potential fire hazards. It's also important to protect wiring from physical damage. This can be done by using conduit or other protective measures. Wiring that is exposed or vulnerable to damage should be avoided. When working with electrical panels, it's important to be extra cautious. The electrical panels contain high voltage electricity and can be dangerous if not handled properly. Always turn off the power to the panel before working on it. Use insulated tools and wear appropriate safety gear. If you're not comfortable working with electrical panels, it's best to hire a qualified electrician. They have the training and experience to work safely with electrical panels and ensure that the installation is done correctly. Before concluding, let's briefly touch on surge protection. Surge protectors are devices that protect electrical equipment from voltage spikes or surges. These surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the protected equipment. It's a good idea to use surge protectors for sensitive electronic equipment such as computers, televisions, and audio equipment. Surge protectors are available in various forms, including power strips, wall outlets, and whole house surge protectors. Whole house surge protectors are installed at the electrical panel and provide protection for all electrical equipment in the home. In summary, understanding the NEC guidelines for electric oven circuits and small appliance circuits is essential for ensuring electrical safety and compliance. Remember that a 240-volt circuit is not always required for an electric oven, but a dedicated circuit is always necessary. The range hood can be connected to one of the small appliance circuits, provided that the circuit's load rating is not exceeded. Always consult with a qualified electrician if you have any questions or concerns about electrical installation. By following these guidelines and taking appropriate safety precautions, you can ensure that your electrical system is safe, reliable, and efficient.